So we're still under model evaluation, but now's the time to check out to see if we got some mediators going on. And let's go back and take a look at our Amos picture. So remember, this is the component scale version. We're going to make a few changes on it real quick. Okay, these values you're looking at here, they're unstandardized. Let me drag this box over here. These are the unstandardized we're looking at. We want standardized. The reason we want standardized is because unstandardized does not explain variance, okay? It's a unit issue. But the standardized estimates gets rid of that unit issue by using standard deviation, standard errors, that kind of thing. All right, then we're going to check it over to the second remote control up here. That's going to show the standardized estimates for us. You see how they all changed. Now, we know that these paths are significant. That's the reason we're checking to see if preparedness is, in fact, acting as a mediator. So we're going to go ahead and look at our path. So this is what we know so far, that A is significantly influencing P, and P is significantly influencing C. So now we're going to check the mediator properties of P. Okay, now we need to use specific numbers to calculate if this thing is a significant mediator or not. We're going to look at the unstandardized regression weights. I'll say that again, unstandardized regression weights, and their SEs, their standard errors from each one of these things. Now, SPSS calls them B weights. These are not the beta weights, okay? The beta weights are the standardized. We're going to use the unstandardized. So we're going to go over to our Amos model, and we're going to pull them off and plug them into a formula. And we're going to use these numbers, these values, to calculate, to see if P is acting as a significant mediator. So A is the unstandardized regression between A and P. B is the unstandardized regression between P and C, and the standard errors are for each one respective. So let's go ahead and take a look at our Amos output. Back to Amos. Okay, so what you're going to do is we're going to go ahead and look at the output text. If yours is grayed out, simply click this the abacus thing, and you'll get a new one. But we're going to go ahead and click that. And so remember, we're looking for unstandardized regression weights. So they will be under estimates. And it's the top one. Even though it doesn't say unstandardized, this one is the unstandardized because the one underneath it is standardized. Okay, so these down here are standardized. These are unstandardized. So we need to look at the regression weights between A and P and C. So here's A and P. There is the regression weight. That's the estimate value. And there's its accompanying standard error. So in here is the regression weight between preparedness and competency. Okay, so these are the four numbers that we're going to need. So we're going to go ahead and put these into a quick table and do some calculations. All right, so here are the numbers from the Amos output that we just showed you how to do, and this is what we're going to do with these numbers. Okay, so A is the unstandardized regression between A and P. B is the unstandardized regression between P and C. Thank you, and here are their standard errors. So we're going to do some calculating now. The first thing we got to figure out is what is A times B. The second thing we got to, this is the hard one, we got to figure out what the standard error is of the A-B mixture, combination, circle, product, whatever you want to call it. And again, everything that we're going to calculate here is one of these four numbers, so it's actually not that bad of a deal. It's just a lot of multiplying and square rooting. So the reason we do that is we're going to take the product of A times B, we're going to divide it by the standard error, the pooled standard error, in order to get what we call a z-score, right? That's a standardized score. And we're going to use the calculated z-score and compare it to a critical z, just like in beginning statistics. So if our mediator is significant or not, this z-score will indicate that, okay? So I'll say that again. Our z-score, if it falls between the critical cutoffs of positive 1.96 and negative 1.96, if you remember those two, those are the two z-scores that will make you a 95% confidence interval. So again, if our calculated z-score falls between these two values, it will not be a mediator. And conversely, if our z-score is outside of that range, or in other words, if it's greater than 0.196 or less than negative 196, that means it is definitely a mediator. So let's go ahead and do some calculations. A times B is simply going to be 0.169 times 1.124, etc., etc. So the product is 0.190. That was easy. Here comes the hard one. So we're going to go ahead and substitute these values into the unknown values down there. And it kind of looks like this. We went ahead and just calculated it out. Don't want to drag this thing on forever here. But we got a standard error of the shared AB regressions to be 0.054. And then we're going to go back to our original Z formula, which we need the A times B. So we're going to take A times B and divide that by the standard error of the shared AB regressions. Standard error of the regressions. So we simply substituted in, let me make sure I got those right? 0.190 goes on the top. 0.054 goes on the bottom. That gives us a z-score of 3.52. And we're going to compare that to our critical value of 1.96, and it's obviously greater than. So our calculated z-score is greater than the critical z-score. So this is true. Therefore, preparedness is significantly mediating the path between attitude and competency. In other words, preparedness is, in fact, a significant mediator. All right, so that's it for the mediator part. I hope this helps. Next stage. Please hold.